Hello everybody. In this video I will try to explain maths or in more detail trigonometry as simply as possible but not simpler. So if you don't know, if you know anything about what is sine, what is cosine, then this video is for you. This is the very introductory video to be able to use basics of trigonometry in geometry or in physics. So let's start with the right triangle. So a triangle that has one right angle here. And let's call this angle to be alpha, okay? And so A is the length of the side which is opposite from the angle alpha. B is the side which is next to this, so these are legs, and this is hypotenuse C of this right triangle. Okay, and suppose you measure A, you measure C, and you divide A by C and you get some number. If you had another triangle, bigger one like this, so I mean this big one, and here it has, let's say, A2, and this big hypotenuse is C2, and you measure now A2 and C2 and divide them. Then you can do this on a sheet of paper. You just draw and measure, okay, you can get this. And it turns out that they are equal in any case. Why is it so? Okay, it's pretty simple because you can easily understand it, because the smaller and bigger triangle are similar, which means they have exactly the same shape but maybe different size. So it's just like you have one picture and you scale it, you make it bigger or maybe smaller. Then the ratios between the sides of the triangle don't change. Yeah, you don't deform your image, for example, if you just scale all the dimensions in the same way, right? So imagine you have some image and you just scale it like this. You don't change one dimension, but you change both in the same manner at the same time. So you can think of that such a ratio of the lengths of the sides for the right triangle doesn't matter how big it is, it only depends on the angle, on one angle of the right triangle, because you know another angle is right angle and the third one is determined by those two. So you can focus on these ratios, and this is how you define the trigonometric functions in the right triangle. So first one is sine alpha, and it will be A over C. What does it mean? It doesn't have to be A over C. It can be X over Y or whatever. What is important is that on top you take the leg which is opposite to the angle alpha, and in bottom of the fraction you take the hypotenuse, okay? Cosine alpha is defined similarly, but now it's B over C. Again, don't think too seriously about these letters. B means the leg which is next to the angle alpha. C means hypotenuse. And the last one, the third one which you may need, is tangent alpha, and this is a over b. So it means you take the leg which is opposite to the angle alpha and you divide it by the leg which is next to the angle alpha. Okay, so let's have some special cases, special examples. Let's first think of the right triangle that is isosceles, which means it has two legs of the same length. So it's A and A, so also the angles are the same, so it's 45 degrees, 45 degrees, so that in total the angles give you 180 degrees as it is in any triangle. So this hypotenuse C, you can get it from the Pythagorean theorem, right? So a squared plus a squared is c squared. So this is frog plus frog. Here you have two frogs. 2a squared is c squared. So c you just square root and you get that c is a square root of 2. Okay? So now you can calculate sine, cosine and tangent of angle 45 degrees. So let's start with sine. Sine of 45 degrees. So as I said, you take the leg that is opposite to the 45 degrees angle. So it's A, and you divide by hypotenuse, which is a square root of 2. So a cancels out. So it's 1 over square root of 2, which you can multiply by square root of 2 over square root of 2. So by 1 you can say, so, to get rid of the irrational square root in the denominator. So it will be square root of 2 over 2. Then cosine 45 degrees. So now it's the leg next to the angle, so a over hypotenuse, so a square root of 2. So look, it's pretty much the same. So we know that the result will be square root of 2 divided by 2. And finally tangent 45 degrees. So it's the leg opposite to the angle divided by leg next to the angle. So it's a over a, so it's just 1. Let's move to another especially important angles. So these are 30 degrees and 60 degrees, and you can find them in the equilateral triangle. Let me draw it. So this is the triangle that has all sides equal, so A, and all angles equal, so each angle is 60 degrees. So if you draw the height of it like this, so here you have right angle, and let's focus on 1/2 of this triangle, okay? So then this is half of the original side, so this is a over 2. Yeah, so here you have 90, 60, so here you have 30 degrees. And how about this height? So this height again can be calculated using Pythagorean theorem. So a half squared plus h squared equals a squared. So it's a squared over 4 plus h squared equals a squared. So I want to have h from this. So h squared is like a cake minus 1/4 of cake, quarter of cake. So it's 3/4 of a squared. so h is a square root of 3 divided by 2, because here you just square root both sides of this expression. So h is just a square root of 3 divided by 2. Okay, so now suppose I want to calculate what is sine of 30 degrees using this picture. So remember, a over c is not necessarily a over c, it can be different letters, and it doesn't have to be the one on the right hand side by the top one. It's just, as I said, the side the leg opposite to the angle divided by hypotenuse. So from the point of view of this 30 degrees angle, the leg opposite to it is this one, is a over 2, and you divide it by hypotenuse, so by a. So a over 2 divided by a is 1/2, because a cancels out. Cosine 30 degrees would be the leg which is next to the angle, so this h, so a square root of 2 divided by hypotenuse, so divided by a, oops, so this is square root of 3 over 2, and tangent 30 degrees is the leg next to the, leg opposite to the angle divided by leg next to the angle. So it will be a over 2 divided by a square root of 3 over 2. Oh boy, this is more complicated. So you can think like one fraction divided by another fraction. So it's first fraction multiplied by inverse of the second one. So this is the second one upside down. So a cancels out, 2 cancels out, so you get 1 over square root of 3. You can again multiply by square root of 3 over square root of 3. So this is square root of 3 divided by 3. I hope you get the idea, so you can calculate sine, cosine and tangent of 60 degrees, so from point of view of this angle. So I will do it faster. So this will be this over this, so a square root of 3 divided by 2 over a, so it's just square root of 3 over 2. Cosine 60 degrees will be this over this, so will be a half over a, so just 1/2, and tangent 60 degrees will be this divided by this, so it will be a square root of 3 over 2 divided by a half, so a cancels out, 2 cancels out, it's just square root of 3. So from these calculations you see that for the special angles like 30, 45 or 60 degrees, the sine, cosine and tangent are have pretty simple values, which can be summarized in the helpful form of a table. So sine, cosine, tangent, and 30 degrees, 45 degrees, 60 degrees. I don't think you need to learn this by heart, because you know nowadays you can easily find such a table on the web, or you can check it easily, but just it's good to know that they have pretty simple values, but if you summarize, they look pretty nice. So sine of 30 degrees was 1/2, sine of 45 degrees was square root of 2 over 2, sine of 60 degrees was square root of 3 divided by 2. So look, everywhere divided by 2, and here you have like square root of 1, square root of 2, square root of 3. Cosine has the same values but in the opposite order, and tangent a little bit different, but here number 3 plays the main role. Okay, and finally, what to do if I have other angle than 30 degrees, 45 or 60. So for example, I need to calculate sine of 23 degrees, or opposite question, I have sine of alpha equals, let's say, 0.82, and question is what is such angle alpha. For this you don't need to, for example, try to draw the triangle which really has 23 degrees and measure all the sides. No, of course people did this in past with greater accuracy than you can get, and you can find the ready tables of the values. So for example, you have sine and you have 1 degree, 2 degrees, 3 degrees, and so on, and you can check the values, or you can find in the values 0.82 degrees and you can see what's the angle, or you can also do it using your calculator, even in your mobile phone, which I will show you now how you can use your calculator to answer these two questions, which are pretty often encountered in physics. I mean, not exactly these numbers, but similar problems.
Okay, so look, this is a calculator on my mobile phone. So suppose I want to calculate trigonometric functions using this. So here I have the little arrow which shows me more advanced functions. So for example, I have sine, okay? And I want to first to check how it works. So let's calculate something which I already know the results. So sine of 30 degrees, and the answer is 0.5, so half. So this is exactly what I expected. In left top corner, I see the little the three letters dig, which means it's degrees, which means that it takes angle in degrees. You should check it because of the angles can be also written in other units than degrees. Okay, so now suppose I want to calculate sine of some not so well known angle, let's say of 23 degrees, and look, I have the solution. It's about 0.39. Okay, and now suppose I want to know the opposite thing. So let's say I know that the sine of some angle is 0.82, and the question is what's the angle such that its sine is 0.82. So I tap the inv, which shows me other functions which are inverse. So I have sine inverse 0.82, and here is the result, about 55. So it means that the angle whose sine is 0.82, this angle has about 55 degrees. So this is how you can use your calculator to help you in trigonometry.